So today we're talking about hyperbolas. Your goal is going to be able to analyze, graph, and write equations of hyperbolas. Now, in the foldable, when you should fold it so that you see hyperbolas and the picture of a hyperbola with your foldable, okay? And then it should open up to the table. But a hyperbola is basically formed when you take a plane, a vertical plane, and cut a tipped cone, and this here and this here are your hyperbolas. So this is what a hyperbola looks like. It's basically two branches. You can have horizontal hyperbolas where they open to the left and to the right, or you can have vertical hyperbolas where they open up or down. Just like before, you do have vertices. You have two vertices that are located on the actual branches, and then of course your foci are on the inside of those branches. The distance between the center of your hyperbola and your vertex is the value of A, and the distance from your center to your foci is the value C. Now your co-vertices, which you really, you can plot them, and this red box that you see in between the hyperbolas, you can use that to help you graph, but your co-vertices are located on that part of that rectangle, and the distance from the center to a co-vertex is the value of B. And yes, A and B are what you use a part of your formula, your general equation for hyperbola, and C, of course, is the what you would add to your center to get your foci. Now, the one thing that hyperbolas have that no other conic has are asymptotes. And as we recall from first quarter, asymptotes are lines that the curves approach but never cross nor touch. And so that's the case there. So when we draw our hyperbola, we want to draw it so that it gets close to the asymptote but never crosses or touches. Okay? Now, the transverse axis is basically like the major axis when it comes to hyperbolas, and that is equal to 2a. And then the conjugate is kind of like the minor axis, but they're called transverse and conjugate because the vertices are located on the transverse axis, and then the co-vertices are located on the conjugate axis. Here are your two equations for hyperbolas, very similar to that of ellipses, but the difference is that there's a minus in between. That's one key difference. And another key difference is, as you can see in your numerators, the x minus h squares and the y minus k squares, either x's will be first or y's will be first. Depending on which one is first, that basically tells you what type of hyperbola you're going to have. If the x's are first, then you know that it's going to be horizontal. Okay? So this way is horizontal. Your branches are going to open to the left and to the right. If your y's are first, then you know that this is going to be vertical. It is going to open up and down. And like before, our center is still H and K. Your vertices, just like before, if it is horizontal, you figure out what the value of A is, and you either add or subtract that from the x coordinate of your vertices. If it's vertical, then you add or subtract the value of A from the y coordinates of your vertices. Foci, very similar to the other ones. You do add or subtract the value of C from your x-coordinate if it is horizontal, or you'll add and subtract it from the y value if it's vertical. The relationship of the foci, in other words, to find the value of C, is this formula of C squared equals A squared plus B squared, old school Pythagorean theorem. All right? Like I said before, you won't have to memorize those set formulas, but you will need to know the general form of a hyperbola for your test. All right, so like I mentioned before, asymptotes are the one thing that these particular conics have that no other conic has, and these are the two equations for your asymptotes. For your horizontal is y equals k plus or minus b over a parentheses x minus h. That's a variation of the point slope form, if you're wondering what kind of form that is for an equation. And then for vertical is y equals k plus or minus a over b, parentheses x minus h. You'll know which one is going to be on top, b or a, based off of the orientation of the hyperbola. If it opens to the left or to the right, that means that your b squared is underneath your y's in the formula. And remember, the equation of a line, the slope is rise over 1. So, which means it's going to be y over x. The variable that's underneath your y's is b, and then the variable underneath your x's is a when it opens horizontally. So that's how you'll kind of be able, if anything, to remember which actually goes with which. Last little bit is your eccentricity is the same formula, E equals C over A. Unlike with ellipses, when it's for hyperbolas, it actually tells you how uncircular it is. Okay, it will always be a number that's greater than 1, and the larger it is, the more uncircular it is. So that means you can have a hyperbola that looks like this, like extra loose, or you can have a hyperbola that's like super, super tight. Okay, so this is an example of being uncircular, and this will be an example of being circular. And that's your basic notes when it comes to hyperbolas. After this, we'll just do a series of examples of graphing hyperbolas as well as writing equations of hyperbolas. So we're going to look at this first example of this particular hyperbola, and we are going to graph this equation. And of course, find all the other information as well. Kind of hard to see, but this is y squared over 9 minus x squared over 25 equals 1. First thing you want to figure out is the orientation. Is this a vertical hyperbola or is it horizontal? Easiest way you can tell is look to see what is written first. Since the y's are written first, it goes y squared. That means it's going to be a vertical hyperbola, meaning that the branches are going to be up and down versus left and right. Okay? And no matter what, the first denominator is always a squared. The second denominator is always b squared. So a squared is equal to 9. B squared is equal to 25. So that means that a is going to be 3 and b is going to be 5. Now, the center of our hyperbola is, of course, 0, 0. There's nothing attached to the x's or the y's, so our center is 0, 0. Okay? Now, from here, let's go ahead and kind of graph that rectangle, because that's going to help us graph the asymptotes as well as our vertices and everything like that. Okay? So from your center, the transverse axis is always the value of 2a. Okay? And the transverse axis is always the direction in which the vertices always lie on the transverse axis, just like how the vertices always lie on the major axis. So from the center, since it's vertical, I'm going to go up 3 from the center and down 3 from the center. Okay? That's going to be one edge of my box, my rectangle. And then from the center, I'm going to go 5 to the left and 5 to the right. From here, I'm going to create my rectangular box. This box is basically just used as a guide, so then that way you can graph your hyperbola. All right? Let's find our vertices. Since it is vertical, that means we're going to add the value of a to the y-coordinate of our center. So it's going to be 0, 3 and 0, negative 3. Again, you just add the value of a to the y-coordinate of your center, since it is a vertical hyperbola. Let's figure out our foci. We're going to add the value of c to the y-coordinate of our center. To find c, we need to do old school Pythagorean theorem. A squared plus b squared. So c squared is going to equal the sum of that, which is 34. C is going to be the square root of 34. So my foci are going to be 0, comma, plus or minus the square root of 34. Remember, you just add it to the y-coordinate of the center. Let's find our asymptotes. We know it's going to be y equals. The formula is y equals k plus or minus either a over b or b over a. Since it is vertical, it's going to be a over b. and then x minus h on the end. Since k is 0 and h is 0, it's just going to be plus or minus 3 over 5x. And that's the equation of our asymptotes. So now I pretty much have all my information to go ahead and graph my hyperbola. If I wanted to, I really could go through and do my asymptotes. You know, I have a y-intercept of 0, and my slope is up 3 over 5 or down 3 over 5. Okay, but the one thing is that we make this box to let us know that one point on the asymptotes is actually the corner of each box. That's why we draw it out. Okay, because if you think about it, if I go up 3 units and over 5 units, I'm right here. I'm right at that corner. So that box really kind of just helps us graph our asymptotes just in case we forget how to go about finding it. And our vertices are located at 0, 3 and 0, negative 3. So all we do is we just draw our branches from those vertex points. And of course our foci. Again, I'm not concerned about where exactly the square root of 34 is on this graph, as long as you have the point written down and your foci are located on the inside of your branches, or located on the inside of your hyperbola, then we're good to go. And that is the graph of this particular hyperbola for y squared over 9 minus x squared over 25 equals 1. Just kind of also harp on a few terms from the other slides. The transverse axis length is always equal to 2a. So the transverse axis was equal to 6, and then the conjugate axis, which is equal to 2b, is going to be 10 because b was 5. And if you take a look from vertex to vertex, that is a total of 6 units. And then from co-vertex to co-vertex is a total of 10 units. All right, let's take a look at the next example. We have x plus 1 squared over 9 minus y plus 2 squared over 16 equals to 1. All hyperbolas are equal to 1. So from here, let's determine, is this vertical or horizontal? Well, since the x's are first, this is going to be horizontal, okay? Whatever is the first fraction, whatever variable is in the first fraction, that is the direction of the hyperbola. But no matter what, a squared is always first, b squared is always second. So that means that a will equal 3, b will equal 4. Let's go ahead and let's find c so we can know when we get to our foci, we'll be good to go. So c squared equals a squared plus b squared. C squared equals 25, so c is 5. And let's go ahead and let's pull out our information, our center, hk. H is negative 1, k is negative 2, so our center is at negative 1, negative 2. Since it opens horizontally, my transverse axis is going to be horizontal, my conjugate axis is going to be vertical. So that basically means from the center, if I wanted to get like the endpoints of my box, I would go 3 to the left, 3 to the right, 4 up, and 4 down. Remember, it's always based off of which direction the hyperbola is open. So since it's horizontal, the transverse axis is always located where the vertices are, which is always, associated with the transverse axis. Okay. So here's our little box to help us graph our asymptotes and use as a guide. Let's go ahead and find our vertices. We take the value of a and we're going to add it and subtract it from the x coordinate since it is horizontal. So if I add it, that's going to give me a positive 2, negative 2. And if I subtract it, it's going to give me a negative 4 and negative 2. So that's where my vertices are located. As we can see, negative 4, negative 2, that is on one point of my box. positive 2, negative 2, that's on another point on my box. All vertices are going to be located on that box. Our foci, we add or subtract the value of C from the x-coordinate. If I add 5 to the x-coordinate, that's going to give me a positive 4, negative 2. If I subtract, it's going to give me a negative 6, negative 2. Now, unlike the other problem where the foci ended up being a radical, this is actually, some nice numbers here. So we can actually plot 4, negative 2, and we can actually plot negative 6, negative 2. Lastly, our asymptotes. It's going to be y equals, since it's horizontal, I'm going to write it over here so I can have the space. It's going to be k plus or minus b over a x minus h. That's the formula for horizontal, for hyperbolas horizontal for their asymptotes. So the value of k is negative 2 plus or minus b over a x minus h. So that's going to be x plus 1. Now, if I wanted to distribute that 4 over 3 over to the x and then combine like terms, then I would actually have the slope-intercept form for our lines that are our asymptotes. But since I already know that the corners of the box are basically the points that are on your asymptotes, I'm just going to go ahead and draw in my asymptotes. And yes, you can do this every single time. That's why I graph the box first, so then that way we can see exactly where these asymptotes are. And now we can just create our branches. We go from our vertices, get really close to our asymptotes, but never cross nor touch. The length of our transverse axes is going to be 6. So that means from vertex to vertex should be 6 units, which it is. And then our conjugate axis from co-vertex to co-vertex should be a total of 8 because we have to double 4, which it is. I'm just showing you that just to kind of harp on that so you guys don't forget about those. Here, so then that way